Sweet. I think we're going to go ahead and get started. Our other recitation leader's running a little late, but welcome to the CBE review for Math 995. It's going to be awesome. So in these first 6 or whatever lessons, we covered factors, fractions, real numbers, exponents, order of operations, algebraic expressions and equations, and logarithms. We're going to start today with factors, which is how we started the year. The factors of a number are the numbers that multiply to that number. In other words, divide and have no remainders. When you factor something, you write it as a product of the numbers, noting there may be more than one way to factor a number. And then we call it prime factorization when a number is written as a product of only its prime numbers. So there's a difference. We're going to see that on this first question. So we're going to find all factors of 36, not just the prime factors. And, oh, I didn't realize it listed them right there. Okay, so first step, does someone want to yell some out to me?
136.
1 and 36, perfect. You know what, I don't like writing that way. I'm gonna write them, I'm gonna list them like that. 1 and 36, okay. Is 2 a factor?
Yes.
Okay, what multiplies 2 to get 36?
18.
18. Okay, is 3?
Yes.
Perfect. 12 is 4. 4 is a factor. Multiplies by 9. 5 is not a factor. 6 is a factor. 7 is not a factor. And then at that point, we've done all of them. And so at this point, you just order them from lowest to smallest. So 1, 2, 3, 4, not 5, not 6, 9, 12, 18, and 36. All right, does anyone have any questions? Okay. Go ahead and move on. Welcome in. Okay, find the prime factorization for 300. This is different than the previous one. We're not looking for all the factors. We're looking for the prime factorization. So first step is we're going to factor, right? This is where we use the tree typically. What goes into 300? 3 and 100, perfect. 3 and 100. Okay, 3 is prime, right? Only multiplies by 1 in itself, so we're going to circle that. What are the factors of 100? 2 and 25. Wait, what'd you say?
2 and 25.
It'd be 4 and 25. No, you're good. 4 and 25, okay. Oh, geez, not 24, 25. Neither of those are prime, so what are the factors of 4?
2 and 2.
2 and 2. Let's circle those. And then what are the factors of 25?
5 and 5.
5 and 5. Perfect, we've done it. So typically you would write this like this. 3 times 2 squared, because there's 2 factors of 2, times 5 squared, okay? Or you can also write it like that. It's the exact same way. 2 times 2 times 3 times 5. Does that make sense?
Yes.
Perfect.
If on the CBE, if we write out just normal 2 times 2 instead of 2 squared, will we get it wrong?
That's a great question.
I don't think so.
Yeah, I think you'll be fine writing it that way. It looks like they do them in ascending order, so starting with the lowest one, so I guess I might have done that wrong. You might want to do it 2 first. Did you say you had a question?
Yeah.
Go for it.
Just how do you know that you want to use 3 and 100 instead of like 2 and 150?
Yeah, that's a great question, actually. And the special thing about numbers is that it really doesn't matter. You can do it any way you want. I'll do it really quickly.
Would you still get the same?
You'd get the exact same thing. Every single number has a unique prime factorization. So that means, how do I get the eraser? Just like that. Oh, geez, what the? It's freaking out. Okay. Every number has a unique prime factorization. So no matter how you do it, you're going to get the same thing. Let's say we go 30 and 5. Then we go 5 and 6. And then we go 2 and 3. Notice how we still have 2 2s, 2 5s, and a 3. Does that make sense?
Yeah.
So that's a special property of numbers is they have a unique prime factorization. No matter how you do it, you're going to get the same thing. Okay, perfect. Did anyone else have any questions on that one? Awesome. Okay, least common multiple sometimes gets confused with greatest common factor, but we're going to talk about them both. Given a set of numbers, the least common multiple is the smallest number that is a multiple of each of the numbers. To find the least common multiple, we list some multiples and find the smallest one that's in the that is in all lists. Note that a number is a multiple of itself, multiplying by 1. So one of those numbers might be the least common multiple. Okay. Let's find the least common multiple of the following numbers. Let's start with 3. Can I put my hand on this, or does it like go to the next slide?
I think you can. I don't know, it's so different every time.
Okay, 3, 6, 9. Do you see how I'm getting these multiples? 12, 15, 18, 21, 24, 27. We'll stop there just because. 6, 12, 18, 24. Okay, instantly we can see between 3 and 6, the least common multiple is 24. Now is 8 a multiple of, or wait, hang on. Is 24 a multiple of 8? Can you multiply 8 by something to get 24?
Yes.
Yes, right? I mean, if we continue this pattern, 8, 16, 24. Okay? So do you see how this is the lowest common multiple? It's the number that is common among these that is the least, that is a multiple of all of them. Does that make sense? So the answer here would be 24. Okay? Anyone have any questions on that? Perfect. Awesome. Jump into fractions. An alternate way of writing division. So typically, or I guess sometimes you'll see it like this. The better way, in my opinion, is like this. And this is true when C times B equals A, right? Like it says here. The numerator is the number in the top, so A would be the numerator, and then the denominator is the bottom, so B. Multiplying and dividing fractions. To multiply fractions, we multiply straight across the numerators, and then we multiply the denominators. Dividing by a fraction, we multiply by the reciprocal. The reciprocal is where we just flip it. Okay, perfect. Perform the indicated operation, give your answer in the simplest form. Okay, so we're dividing. First thing we're going to want to do, I'm going to rewrite the problem. Except we are going to multiply by the reciprocal. What is the reciprocal of 15/8? 8 over 15, okay? Okay, now let's notice this right away. What's a common factor between 8 and 24? Or a common, factor.
4.
Or even higher, 8, right? So what happens if we pull out an 8 over 8, and these 8's go away, and we get 35 times 1 over, 3 over 15. Does that make sense how I did that? Okay, and then a common factor here is 5, right? So if we divide 5 from the top and the bottom, we get 7 over 3. Oh, geez, that's not a 3. Over 3 times 1 over 5. Does that make sense how we did that? Yeah, go ahead.
Can't you just multiply across and then simplify from there?
You certainly could, but you might get some pretty nasty numbers. 35 times 8 is 280, and 24 times 15 is 360.
Wait, you can do that in your head?
I do this all the time.
Holy cow.
This is all I do, man.
For the 5, you put 5 instead of 3. It should be.
Oh, you're right. You are totally right. Thank you for catching that.
You're fired.
3. Oh my gosh.
Are these just the questions that are on the CBE?
They're similar
Different
types
numbers.
of questions, yeah.
Just
Go
same
ahead.
concept?
Okay, so you multiply by the reciprocal, and then you look at which one they have in common, and then whichever one they have in common, that's what you multiply by again, and then it will cancel out.
Yeah, so a different way of thinking about it is, let's say, okay, we rewrite this 35 over 24 times 8 over 15, right? So we could rewrite this, kind of you were asking, 8 over 24 times 35 over 15. That's the exact same. Does that make sense?
Yeah.
We just switched. You can do that when you're multiplying, okay? Now let's take a look at this. Imagine if you divide up a pie into 24 sections, okay? If you eat 8 of them, that's the same as eating a third of the pie, right? 8 24ths is the same as 1/3, okay? This eraser's not great. 1/3, oh geez. It's freaking out on me. Okay, 1/3. And then the same thing here. We simplify in the same way. Does that make sense to everybody? And we kind of already went over that one before. Okay, do you want to pick up here, Britton? This is our friend.
Sorry I'm late. I ran from the engineering building. Okay. So, sorry. Okay, adding and subtracting fractions. Did you just do addition?
We did
multiplication.
just
What
barely.
were the first two questions about?
Just factoring in least common multiple stuff.
Okay.
Okay, so remember how adding and subtracting are like super similar? So this is the procedure for adding fractions. Well, it has the same procedure as subtracting fractions. And in order to add them or subtract them, the denominators have to be the same, right? So the first thing is going to be rewriting fractions with a common denominator, using the least common multiple, and then we can add or subtract the numerators and keep the common denominator. Do I just tap to make it?
Yeah.
Cool. All right. So we've got 5 over 2 minus 5 over 4. So what is the first step for solving this?
Make the bottoms the same.
Make the bottoms the same. So
So you got a factor. Let's figure out. They both go in 2, which would be 8.
exactly.
Can you technically do 1?
Not really, because then you would have decimals. Because if you were to...
Not 1, 4.
You could do 4.
Oh, yes, precisely. You could do 4.
Are we simplifying as far as we can go?
Yes, and so the reason that we can go into 4 is if we write out the denominators, we've got 2. The factors of 2 are just 2 because it's a prime number. And the factors of 4 are 2 and 2, right? And so in this case, what do these have in common? They each have 1, 2. And so we can ignore one of these and we can just look at these 2's, and 2 times 2 is 4. That's going to give us our least common multiple. So we know the least common multiple is going to be 4. In order to get a 4 right here, we're going to need to do 2 over 2 times 5 over 2. And that's going to give us 10 over 2. Not 2. Do you erase on this?
It's kind of weird. So you like tap in the middle and then you tap there and then you tap the eraser square.
Gotcha.
And then you have to go tap that to get your marker again. Yeah, it just freaks out for some reason. You just tap on the side.
Well, yeah, but like, it sent me back.
Yeah, it just does that. I don't know why.
All right. 10 over 4. Cool. Minus 5 over 4. Now, we have the common denominator, and now we just subtract the numerators, which gives us 10 minus 5 is 5. So we get 5 over 4. Questions? Cool. Yeah, solution is 5 over 4. Cool. Do we want to?
Yeah, we can do whatever you want.
Okay.
Do every other or
How many? You did 4?
I think so.
Then I can do
Like every 4-ish.
Okay. Simplify the complex fraction. Give your answer in lowest terms. All right, so we got negative 5 over 6 divided by 1 over 3 minus 1 over 4. What do you guys think our first step should be?
The bottom.
What about the bottom?
Make it all the same.
Okay, so simplify the denominator. What do you guys think?
Good idea.
I agree, it is a good idea. So we've got 1 over 3 minus 1 over 4. And so let's find the least common multiple. 3 has the factor of 3, and then 4 has a factor of 2 and 2. So do these have any in common? They do not. As a result, we're just going to multiply them all together. So the least common multiple is going to be 12, which means that we can just multiply 3 times 4 and 4 times 3, along with the numerators. And that will give us 4 over 12 minus 3 over 12. Everybody following? Cool. And so 4 minus 3 gives us 1 over 12. That's in the denominator. So we can now rewrite it as negative 5 over 6 divided by 1 over 12. What do we want to do from here?
Multiply by the reciprocal.
Multiply by the reciprocal. So we got negative 5 over 6 times the reciprocal of 1/12 is exactly 12 over 1. And we could multiply 5 times 12 and then divide it by 6. Or we could just recognize that 12 over 1 is equal to 6 times 2 over 1. And we can cancel out the, what the heck? We can cancel out the 12, the 6 and the 12, so that we get rid of the 6 in the numerator, 6 in the denominator, and that gives us 5 times 2 over 1, which is just negative 10. That makes sense?
And then you would just carry the negative across. to make
Yeah.
it 10.
Yeah, we would just carry the negative across because we have a negative number that 5 over 6 times the positive number 12 over 1. All right. Real numbers. So within the real numbers, I mean, we're only going to be working with real numbers in this class. But the real numbers contain the natural numbers, the whole numbers, and the integers. And then a few others. But just as a reminder, the natural numbers, they are like whole numbers, 1, 2, 3, 4, 5, 6, if we're just counting. Like we don't count using decimals, or at least I don't. Maybe you guys do. We don't use decimals, no fractions, and there are no negatives, and there is also no zero. So these are only extant numbers. Like I have 2 chairs. I can't just have 0 chairs. If I have 0 chairs, I don't have anything to have. And I can't have negative chairs, right? So these are natural numbers. They're numbers that exist in the real world. Whole numbers, basically the same thing, except we also add in 0. Why? I don't know, but we do. And then integers is just the extension of the whole numbers into the negatives. So that's how we can do stuff with subtraction. Yeah. Any questions regarding those? No? Cool. And then as a continuation of these numbers in real numbers, rational numbers are anything that can be written as a fraction, or, the way I like to remember it, a ratio. So any fraction is a ratio. If you can write a number as a ratio, as a fraction, it's a rational number. The number pi, for example, goes on for infinity. It can't be written as a fraction. It's an irrational number. Irrational numbers, like I said, with pi, they're decimals that not only don't stop, but they don't have a pattern. There are numbers that have decimals that don't stop. For example, if I have 1 divided by 3 is equal to 0.3333, continuing 3. So obviously that decimal isn't going to stop, but it has a pattern. Whereas irrational numbers don't have a pattern and therefore can be described by a simple fraction. And so the real numbers are any number that is either rational or irrational. And a lot of the time we'll use a number line to represent those. And imaginary numbers are not allowed, so I can't have 5i. We can't use I. You guys don't need to worry about imaginary numbers in this class, but yeah.
So is like 5 a real number?
Yes,
Okay.
it exists, right? Yeah.
I was just wondering because it doesn't say on there that like natural and whole numbers are real numbers.
So
Yes.
they're all contained. You can.
Yeah, and also it technically does, it says any number that is rational or irrational. 5 can be represented by a fraction, 5 over 1. And so we know it's rational and therefore it's a real number.
Okay.
So any of if we go back here, so any of these are also rational numbers. Except for 0, I don't know, 0.
0
Yeah,
is
zero.
technically rational.
Irrational number? Okay, yeah, 0 is technically a rational number too.
0 over 1.
Awesome.
Wait, I have a quick question about those.
Yes.
So in class, she gave us a little like chart that goes down. Do you remember that? Like real to top, to rational, to integers, to whole numbers, to natural numbers.
Yeah.
Is that kind of the same thing as that?
Yeah. Yeah. So like if you were to look it up online, you would see a lot of pictures like this, because it's kind of like a visual giving you an idea of like here are all the real numbers. Within those, you have the rational numbers, and then you have the integers which are within the rational numbers, so on and so forth. So it's the same concept, but just a visual explanation. Yeah. So we're gonna see if we can figure out what number sets the following numbers belong to. So negative 15.25. What number set would that belong to? Out of the real, rational, integers, whole, or natural numbers? Would it be in the imaginary numbers?
No.
Okay, cool. So that's one narrowed down.
Is it rational?
What do you guys think? Is it rational?
And real?
Is it real?
Integer?
Yes. So the thing is, we like for simplicity's sake, we can go to the on this board, we can go to the largest circle. So obviously the number 1, for example, is not only a natural number, it's also a whole number, it's an integer, it's a rational, and it's a real number. So sorry, we're gonna go to the smallest one. So like I would say that 1 is a natural number, whereas negative 1 would fall into integers, right? Okay, so in this case, negative 15.25 it would qualify as a rational number. Because while it is negative, it has to be described using a fraction. In this case, I think it would be negative 61 over 4 is how we would have to describe that using whole numbers, using integers.
And so just to clarify, because it's rational, it's also an integer, a whole number, and natural.
No, so because it's a rational number, it's also a real number.
Okay.
Integers can't have decimals.
It does not qualify as an integer because we have to use a fraction to describe it, right? So if it were just like negative 61 or negative 4, then we'd be chilling. It would qualify as an integer. But because it's got that decimal in it, we have to use a fraction. And so that forces it to be a rational number. Does that make sense? Sweet. All right, what about 4? Four's a real number, right?
Yes.
Okay, cool. What
Whole,
else?
natural, integer.
I'm hearing like natural, integer, rational. Which one?
The whole circle.
A whole circle. So are you saying it's
Natural, whole.
natural? Okay. Yeah. What do
If
you
you
guys
say it's just natural, does that mean it applies to all of them? And you don't have to type in the rest?
Yeah, so like with the way this is drawn, rational
Well, I mean,
numbers
on
are
like
in
the
real
test.
numbers, integers are irrational, so on and so forth. So natural numbers by definition also qualify as all of these things.
Okay.
So if I say it's natural.
So if I were to put in all of them on the test, it would mark me wrong even though I'm right?
I don't think you guys are gonna get a question like this.
Except for irrational. 4 is not irrational. So if that's one of the options, don't select.
Yeah, sorry, well, because is
Yeah, it should be more.
off on the side, you'd have irrational. Yeah, there we go.
That was conflict.
Yeah, so irrational is in real numbers, but it's disconnected from everything else. If something's natural, it qualifies as all of this and this, but not as irrational. Irrational is kind of separate. It's kind of hard for you guys to see, but. Yeah. So 4, like you said, it would be a natural number, so it's also a whole integer, rational, and real number.
How long is this review class?
30-something questions.
Yeah, it's 30-something questions. I think it's supposed to be like an hour, isn't it?
I mean, I'm not trying to be rude, but I have my CBE test is like an hour, so I just wanted to make sure.
Okay, yeah, I mean, yeah, so it should be about an hour. I mean, feel free to leave whenever you want, and we're not forcing you to stay here.
Alright.
But, yeah, and then, okay, so we did negative 15.25, 4, and then what about pi?
Decimals.
Irrational?
Yeah.
Yes, it would be irrational. Because it has decimals, but it has no pattern. And we can't describe that with a simple fraction. So, be cool. Any questions?
Are you really telling me pi doesn't repeat once?
So, it technically does, but it's not a pattern. So, pi, it goes on to infinity in an unpredictable pattern. So it goes like 3.1415926535897 3, 2, 3, 4, 2, 1. Something like that.
4, 3, 8, 2, 6.
Oh, it's 3432826. 3, 4,
I don't think it's particularly.
3826. You're right. It's not important, but basically, there's no pattern to this. It can't we have tried to describe it using to approximate it using fractions, but we can only get to a certain number of decimal points before we get before it like veers off and gets a different number. So we can get close, but this is going to go on for infinity in an unpredictable pattern. So, yeah. Yeah, so negative 15.25 is in the rational and the real numbers. 4 is all of them, and then pi is in the irrational numbers. All right, do you want to go on exponents?
I almost wrote on it with this.
Exponents. Okay, an exponent is how many times something is being multiplied by itself. Here are some useful exponent rules. If you have the same base but a different exponent, you can add the exponent. If you have something raised to a power and then that whole thing is raised to another power, you can just multiply the exponents. Remember, like same base once again. If you're dividing something the same base, and by base I mean A. A is the base here, and then B and C are the exponents. You're dividing something to a power divided by something else to a power, you can subtract the exponents. And then something to a negative power is just you inverse it and do 1 over that thing. And then this one is very important. Anything to the 0 power is 1. Okay, perfect. We're trying to multiply these things together. Let's see. First of all, let's take care of our numbers that we have here. 2 and negative 5 is what? Negative 10, okay? And then I'm going to write it out on this first one. I usually, oh geez. What happened? That's not good. You want to go see? Sure. Oh. Go back to. What should it be? This. Okay, yeah. Sharing
Okay, so it's
call.
there.
Perfect.
There we go.
Okay, I'll just not touch it. Okay, I'm just going to write it out on this first one. We have y to the 4th times y to the 3rd. So I'm just going to write it out on this first one. This is y to the 4th, and then this is y to the 3rd. Okay? So how many y's do we have being multiplied together? Do you guys see how that's y to the 7? Perfect. And that is our answer. Negative 10 y to the 7. Awesome. Okay, this one is a little bit more tricky. So what we can do is, like that one rule said, if you have something to a power, a to the b to the c is the same as a to the b times c, okay? So this power, this raised to the negative 4, is going to go to each of these. So we're going to rewrite the numerator as 2 to the negative 4 and x to the positive 4. Does everyone see how that happened? Negative 1 times negative 4 is 4. Okay? And then 2x squared. What is that going to give us?
4x.
4x squared. Right, perfect. Okay, now from here, what are we going to do? How are we going to get rid of this negative exponent?
You get a positive.
Yeah, and when we make it a positive, what do we have to do?
Move it to the denominator.
Move it to the denominator, exactly. So I'm going to erase this from, oh geez, it revealed the answer. Oh boy. What's going on here? Oh.
This is our CBE review.
Okay, that seems wrong. Is that answer right?
X squared.
Because this should be 2 to the
Let's see.
4.
No, it makes sense. Yeah.
Did I mess up something? 2 to the 4.
No, because it's going to be, you're going to have 1 over. It's going to become 1
Sorry,
over
let me
16,
erase
1 over
this.
16x.
Sorry, oh jeez, sorry. Let me erase this. Okay, so we had our 2 to the negative 4 x to the 4. And then we had 4x squared. Okay, we have an x to the 4 on top and an x to the 2 on the bottom. How does that simplify? In other words, we have x times x times x times x divided by x times x. How many x's do we have left? 2, exactly. So we're going to erase that. X to the 2. That should totally be
Yeah, I got
x to the 64.
x squared over 64.
Yeah, so this answer is wrong.
Whoever wrote this.
So remember, 2 to the negative 4, that goes to the denominator. We flip the sign. Okay. And the sign magically becomes positive. Not magically, but... Okay. And then 2 to the 4 is what? Does anyone know what 2 to the 4 is?
16?
16, yep. And then 4 times 16 is 64. So that is our final answer. That make sense?
See, how did the -1 and -4 interact again?
Yeah, so it's x to the -1 to the -4. We're just ignoring that. And when you have something to a power to another power, you can just multiply the powers. So -1 times -4 is +4. Does that make sense?
Yeah.
And you get a +4 on top and an x squared on bottom. Perfect. Okay, order of operations. Do you want me to do like one more? Okay, PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. It's important to remember that these are together. It's not like multiplication and then division. It's multiplication, division are one step. And then same with addition, subtraction. Please excuse my dear Aunt Sally. Algebraic expressions and equations. Algebraic expressions are mathematical statements. They don't have a value and we cannot change. They have a value and we can't change the value. We add like terms and divide out common factors. Equations equate things. They have an equal sign, right? And we can do lots with them as long as we don't change the truth, meaning that one side of the equation must always be equal to the other side. So we must do to one side what we do to the other, and vice versa. Okay, let's start here. What is the first step? What should we do first here?
Absolute values.
Yeah, so what's inside the absolute value?
3 minus 6.
3 minus 6 is what?
-3.
-3, but what's the absolute value of -3?
3.
3, perfect. And then we still have, what's 3 squared? 9.
36? Nope, 9.
Okay,
No, I thought it was 3 cubed. Never mind. That's all I'm thinking.
you're good. And then what's 8 minus 4?
4.
4, perfect. Okay, now this is just simple arithmetic. What do we do on the top?
+9 or -9?
It's going to be -9. Because if you were to have parentheses here,
I see what you're saying.
then it would be -3 squared, but it's 3 squared, right?
Might have to explain that more for me.
Okay, I'll reveal the answer. We'll finish doing this one real quick and then I can explain it. 8 plus 3 is 11, minus 9 is 2. Oh, geez. 2 over 4, okay? Which is 1 over 2. And then I'll explain that, like, the kind of principle. If we have, oh, geez. Minus, sorry, I keep messing up. -3 squared versus -3 squared. So we look at this, a minus sign, a negative sign is essentially just a subtraction sign, right? We're subtracting 3 squared. And if we remember our order of operations, exponent comes before subtraction, right? So we evaluate the exponent first. We get 3 to the 3 squared, which is 9, and then we tack on the exponent. But here we have parentheses, and parentheses override everything. So now we're looking at -3 squared, and -3 times -3 is 9. Do you see the difference there? Does that make sense?
Yeah.
Perfect.
Quick thing, I'm stuck on 3 minus 6. How come that isn't -3 and instead positive?
It's a great question. These are absolute value signs. So the absolute value is the distance of a number from 0. So the absolute value of -6 is 6. That make sense?
Yeah. So it's only counting it as, crap, I forgot the number labels, but it can't be a negative if it's looking for absolute value.
Yeah, I mean, if something is inside the absolute value signs and it's negative, you just change it to positive. Does that make sense?
So it changes it to a whole number.
Yeah, that's what I was looking for. Oh, there
Yeah,
they are.
that makes sense. Okay, what are we gonna do here? What should we do first? Distribute, yes. Okay, what's 2 times 4? 2 times 4k? 8k. And then what's 2 times negative 1? Minus 2, okay. Now we have a negative 5. What's negative 5 times k?
Negative 5k.
Negative 5k, and then negative 5 times 2. Negative 10. Okay, now we can combine like terms. Oh, geez. So we can't combine an 8k and a negative 2. Those are different things. But we can combine 8k and negative 5k. What is 8k minus 5k? 3k. And then what's negative 2 minus 10? Yeah, I should have crossed that out so you couldn't see it.
I wasn't looking.
Okay, you want to take what happened? Is that all? There was like 36 on the one that we had.
How many problems have you guys gone through?
11.
Well,
That's-
there's only 10 questions on the test, so.
Let's hope they represent them pretty well.
I could have sworn there was like
There
30.
should be more,
Let me check.
because we haven't covered all the material.
Yay, we gotta get out of it.
That's not right. Okay, let me mess around with this for a second.
Okay.
And I'll go ask Carolyn.
Okay, do you guys have any questions about anything? Like, I know I talked to a student yesterday. She had a lot of trouble with order of operations. Do you guys have any questions regarding that?
The first CBE, what topics is it gonna have in it?
The first packet I was told.
The first packet.
The whole
So
first packet.
everything that's covered in the first packet is going to be covered in.
I was basically told the
I would not
packet is a
expect-
test.
Yeah, I wouldn't expect anything from the second packet. There isn't anything from the second packet, the third packet.
So then can we go over more things in the first packet?
Yeah, like if you guys have questions, we can go over other
I
stuff.
don't know which one that
Logarithms
was.
second packet, right?
Logarithms is first packet.
Logarithms is
But-
second.
Could you go,
She put some logarithm stuff in the first packet.
That's great.
could you
Yeah.
go over the one that was wrong?
Oh yeah. We can do that one. Yeah, it was this one. This one. You want to go over this one?
Yes.
Okay, cool.
You can just clear the screen if you want.
How do I clear the screen?
You go to that and then it says like, go to like where you do the eraser and then.
Eraser's gone. Oh, here we go. Okay. Okay, cool. So you want to just go through this one again? Okay, so we got 2x negative 1 to the negative fourth over 2x squared. So let's start by simplifying the numerator. And that's going to give us, well, we distribute the negative 4, right? And so we're going to do 2 to the negative fourth times x to the negative 1 times negative 4, right? So that's going to be equal to 2 to the negative fourth times x. Negative 1 times negative 4 gives us 4, right? Over 2 squared, which is 4, times x squared. Everybody following? Makes sense?
Nope, same one. This one? Same one.
No, sorry, not math issues, like technology.
Is this everybody on the same page?
What was the final answer?
Quick thing.
This final answer is incorrect. Well, we're going through it again.
Like 36 lines out.
Okay.
And so we've got,
It's okay, it'll.
what's up?
Isn't it, what's the bottom, 4? Isn't it 2 multiplied 4 times?
Down here.
Um,
So this, because we distribute this, this squared, right? So it becomes 2 squared times x squared. right? And that's equal to
Oh, yeah, yeah.
4 times x squared. And so we've got 2 to the negative 4 times x to the 4th over 4 times x squared. And if we want to keep on simplifying the numerator, 2, you guys remember what happens when we have a negative exponent, right?
Here, question.
Yeah.
So we're not actually multiplying the -1 and the -4, we're distributing the -4 to 2 and x to the -1?
Yes, so what happens when we distribute it, it goes to the 2, because really this can be rewritten as 2 to the 1 times x to the -1 all to the -4. So when we distribute this, we're multiplying it.
So how come we're distributing it instead of using the property where it's like x a plus b when you have the outside parenthesis and inside parenthesis exponent?
That's exactly
Oh.
what we want, I think.
Yeah, so we have the property x to the a to the b is equal to x to the a b. Right?
Also a times b, not a plus b.
Exactly.
Okay.
A plus b would be x to the a times x to the b is equal to x to the a plus b. Does that make sense?
Yeah.
Cool. Awesome. All right, so going back to the numerator. Oh my heck. We've got 2 to the -4th times x to the 4th. So what happens when we have a negative exponent?
Goes to the bottom.
Yeah, it goes into the denominator. And we treat the exponent normally. So it becomes, so we know that 2 to the -4th is equal to 1 over 2 to the 4th. Yeah. What the heck? There we go. 2 to the 4th, which is equal to, what is 2 to the 4th?
4. No, 16.
16. So we got 1 over 16 times x to the 4th, right? And we can just rewrite this as x to the 4th over 16. Now we want to go over to the denominator, and we can't really simplify it any further, so we can just rewrite it all as x to the 4th over 16 over 4x squared. Now we've got a fraction divided by not a fraction. What do you guys think we can do to like simplify this further? It's a horrible looking x, but what do you guys think? Multiply by what?
The reciprocal.
I like the sound of that. So that is equal to x to the 4th over 16 times the reciprocal of the denominator, which is 1 over 4x squared, right? And now we can cancel out this x down here and 2 of these x's up here. That gives us x squared in the numerator, and then we got 16 times 4 an arrow in the denominator. So it's going to be x squared over, what's 16 times 4? 64. You guys have any questions on that? Does that make sense?
So that's the right answer.
Yeah, the correct answer is x squared over 64.
Oh, okay.
I don't know how they got x squared over 4, but yeah. Are there any other questions you guys want to go back to? Nothing at all. You guys are like 100% ready?
I wish that we had the full slideshow. I don't know.
We can, like, oh, you can't even see it? Okay.
Can we go over our practice test?
Sure, yeah. Yeah, we could go over some questions on the practice test.
Do like just a practice test altogether?
Different notes on tech questions.
Yeah, we have to keep this screen up, so I guess we just write the questions out, just so.
Yeah.
What is
There's
the
a
practice test?
blank page.
It's on Zoom right now.
It's on Top Hat.
No,
Oh,
this is
my
just something because the whole Top Hat system screwed up. So I have to go back in and
Yeah,
put in the
practice-
questions that
Practice
were-
test is in Canvas.
Oh, sweet.
Yeah. If you go to Canvas, it should be in there. I can just pull it
Why is it
up
not
here
there?
and then write down questions. Yes.
I had one from the practice test that I needed help with,
Okay, yeah,
but
yeah.
it's the same as the one we just did, but we could do it again. for
Sure, we could do it, yeah, we can do the same kind of thing again.
You want me to just show it to you?
Yeah, just show it.
I took a picture of it
Yeah.
last night. So it's that one.
Okay, cool. All right, so the question is 3x to the fourth to the negative 3 over 3x to the 0. Ooh, me gusta. Alrighty, so we got 3x, was it negative fourth? Was it to the negative fourth?
Yeah.
Yeah. Cool. 3x to the negative fourth to the negative third over 3x to the 0. What do you guys think should be our first step?
Reduce the bottom to 1.
I like that idea. Remember how a number x to the 0 is the same thing as 1. Any number, name a number. If you put it to the 0 power, it's going to be 1. Makes our lives very easy. So we can just look at the numerator. That's going to be 3x to the negative fourth to the negative third. Now, our next step is we're going to multiply that negative 3 down to the 3 and the x to the negative fourth. So that gives us 3 to the negative 3. X, negative 4 times negative 3 gives us,
12 or 12.
we got 12, positive 12. And we can rewrite that as 1 over 3 cubed x to the 12th. And 3 cubed is,
27.
yes, 27.
Isn't it a negative 3 cubed?
Yeah, it was 3 to the negative 3, right?
Oh, okay, so
And so we just put that in the denominator, took the reciprocal, so we got 1 over 3 cubed times x to the 12th, and so that is going to be x to the 12th over 27. Anybody have any questions on that procedure?
I have a question. Could you just flip the whole top bit to the bottom and then that like cancels out the negatives, or do you have to distribute first?
So, yeah, you could, if we did, so you're saying like we could rewrite it as 1 over 3x negative 4 cubed like that?
Yeah.
You could. And then if we just simplify that, that's going to be the same thing as 1 over 3 cubed x to the negative 12th.
And then you have to go back.
Yeah, and so if we continue with that x to the negative 12th, simplifying it, that's just going to bring it up to the numerator, and it's going to give us the same answer. So we want to see what that looks like. That would be 1 over 27, 1 over 12, and that's the same as 1 over 1 times 12. Why did I write 12? Yeah. X to the 12th is not necessarily equal to 12. X to the 12th times x to the 12th over 27. And so that gives us that.
As long as our problem isn't a fraction, can we start, and it has a negative exponent, can we start with putting a 1 above it?
To get rid of the negative, you could. It would give you the same, like doing what we did right here. It would give you the same answer. It's just a different way of going about it. Yeah. Any other questions about this? Are there any other questions you guys want to do from the practice?
Can you come look at mine really quick? Because my teacher teaches me a different way,
Okay.
and so I'm wondering if. I'm just like getting confused now, because now there's different ways to do it. So this is how she teaches us how to do it,
Okay.
which is we write it out differently. And we kind of combined it down to the bottom.
Yeah, so that's just another way of looking at it, more of an expanded form.
Okay.
Really,
So this is a positive or negative 12?
So if it's a positive, if it's a negative 4 here and a positive 3, then it will become a negative 12, because negative 4 times 3. But if it's a negative 3, then it becomes a positive 12.
So if I were to type it in this way, would I still get the question right?
If you have a positive 3 up here, then yes, you would get it correct.
So we don't have to write it like as a fraction or anything?
Well, because the thing is, we did it with a negative 3 as an exponent,
Mhm.
and so that would have put the 27. Because you would have had 3 to the negative 3 when you simplified it up here.
Mhm.
Does that make sense? Why?
No.
Yeah, because you did it with a positive 3.
Okay.
Oh.
I just want to show you guys this. This helps people understand negative exponents a lot.
Oh, because it
So
was
I'm sure
negative, but you can't-
Positive exponents make sense. These ones here are like, it's intuitive. It's 2 to the 2 is 4, 2 times 2, right? But a negative exponent and even a zero exponent, that doesn't really make sense. It's kind of mysterious.
Okay.
But let's kind of notice a pattern. What's 2 to the 1? Someone give it to me.
It's just
2 to the 1 is 2.
What's 2 to the 2?
4.
What's 2 to the 3?
6.
8. What's 2 to the 4?
16.
Perfect. Now let's notice a pattern to get to these mysterious negative ones. How do you get from 16 to 8?
Divide by 2.
How do you get from 8 to 4?
Divide by 2.
And 4 to 2?
Divide by 2.
Okay, and we're going to keep dividing by 2. You guys see it now? Does it make a little more sense? I think this helps some people. This is why it is the way that it is. Does anyone have any more ones from their practice exams or?
Can I tell you one?
Yeah, go for it.
It's 3x
Oh,
to
sorry.
the power of 5,
All of it to the power of 5?
like the x,
Just the x to the 5?
and then all of it is net to the power of -1,
Negative 1?
and that's over 3x to the power of 3, like that.
Yeah, that's the one I'm doing right now.
Okay, perfect. Now, as we kind of talked about before, there's 2 ways we can do this. We can either, do that first, or we can flip it to the bottom. I'm going to flip it to the denominator. So this, goes to the denominator, and we change the sign. This gives us 1 over 3x to the 3rd times 3x to the 5th to the 1st power. Now, anything to the 1st power is just that thing, right?
Right.
So we don't really need that 1. So now all we have is 1 over 3x to the 3rd times 3x to the 5th. Okay, now how are we going to simplify that? I'm going to erase this previous part.
We can add the exponents here, right?
Yeah, exactly. Add the exponents. So now, oh, geez. Don't know why it does that always. So now we got 1 over 3, and we still have the other 3 times 3. And then what would this be? X to the what?
The 8th.
8th power. Perfect. And then what can we do here?
9.
Yeah, exactly. That just turns into 9. And that is our answer. 1 over 9 times 8, 1 over 9x to the 8th. Make sense?
The exponent's a negative. So let's say it's 3x negative 5 to the 1
Negative 5 to the negative 1?
to the positive 1.
So you're saying, what if we Oh my gosh. What if we were to go like, this is negative, or sorry,
It would be -5 to the positive.
so -5 here,
Yes.
just like that? Okay. Well, anything to the 1, like I said earlier, is just itself, so we can get rid of these parentheses. I gotta be careful so I don't erase anything else. This doesn't like me very much. Okay, now what we're gonna do, well, let's notice this here. What's 3 divided by 3?
1.
1, exactly. So that no longer becomes relevant because 1 times anything is itself. Now we have this x to the -5 over x to the 3. How do we get rid of this negative exponent?
Or 1 at the top of it.
Exactly. Or move it to the denominator. So now we have 1 over x cubed times x to the 5th. And then what do we do with that? What's x cubed times x to the 5th?
X to the 8.
Yep, exactly. That makes sense? There's your answer.
Well, I have the question, and instead of the 3s, it's 2s, and the bottom was a 4, so I'm guessing I got 1 over x to the 4 to x to the 9, or x to the 5.
Be the same procedure if you had different numbers. You can take the next one if you want. Okay.
What time do we want to be done? Because it's 5:30 right now.
Maybe we'll do one more.
Okay.
Can we do a logarithm one?
Yeah. I didn't think logarithms were on this test. Maybe
I don't
I'm not seeing
think they are.
Let me check, and if they're not, we'll do it next time.
Prime
It's
factorization.
just the memorization of what goes where, really.
This has to do without a calculator, but they give you a calculator.
It might not have logarithms.
Okay, so there won't be logarithms. It's mainly factorization, operations with fractions, stuff like that. And then simplification of expressions. So
I feel like we've covered pretty much everything.
yeah, like looking through this,
We don't have to do one more unless someone has a specific one.
yeah, you guys are good to go. If you have a specific question, feel free to say. We're down to
That's
answer
the
it.
one we just kept going over, yeah.
That's probably the hardest one on there.
Just that one? All right, we can do another one.
Yep.
I just I got the same question.
Okay. So let's do,
It's not the answer.
we're gonna mix it up a little. We got 2x to the 4th to the -1 over 2x to the -3rd.
Is this similar to that?
So
We could also go over that.
what do you guys think should be the first step for this one?
Flip it.
Flip what?
Both of them.
Flip both?
Yeah.
You guys agree?
Wait, you can't take a negative that's on the denominator and flip it to the numerator to make it positive, can you? You have to put some in.
No, you can flip it to the numerator.
Okay, so it just has to be inverted, doesn't matter which way.
Yeah, so we're gonna flip it, and I'll write it out why exactly that is, because we can rewrite this as 1 over 2x to the 4th over 1 over 2x to the 3rd, right? And if we multiply it by the reciprocal, that's the same thing as 1 over 2x to the 4th times 2x cubed over 1, which gives us 2x cubed. That is a 3, not a parenthesis. Wow.
I just did that once, I used to just run duos.
Okay, 2x cubed over 2x to the fourth. So yeah, we just flip those. Does that make sense why we flip them? I'm seeing some confused faces.
I don't know why we do, but I know we do.
Yes.
Yeah, so if we, like looking at this, if we rewrite it, because this is equal to this, right?
You don't need negative out front.
Right?
Yes.
This is equal to this.
And then because this is.
Then if we've got
this whole thing.
a fraction divided by another fraction, we just multiply by the reciprocal, right?
Okay.
So
1 over.
we got this right here, multiply it by, wait, this is the same thing, 2x to the fourth, 1 over 2x to the fourth, 1 over 2x to the fourth.
Times x to the third.
Then-
and that's all in the denominator. Does that make a little more sense?
These are reciprocals, so this is the reciprocal of this.
So theoretically, when you flip it
You want me to draw it
both,
out here?
that's just the answer. But obviously after you distribute it and stuff.
Yeah, you gotta distribute. We still need to simplify it a little bit more, but if you got a negative, like everything within a negative exponent in the numerator and the denominator, then you can just flip them. It's just like a shortcut you can do, but this is why we do that. And so that, like, does that help? Does that clear it up? Cool. So if we have this now, 2 to the third x cubed over 2x to the fourth,
You don't need it because it's to the 1.
and that's going to be
And
27
then it's 3x to the 5.
x
And then now that's
cubed
equal to 1,
over
right?
2x to the fourth,
Okay, now
and we just simplify that x,
You want to make sure you get rid of the parentheses, right?
Get-
Otherwise, you're gonna have to multiply.
cross that out,
Well, it doesn't.
and that gives us 27 over
So,
2x.
3 to the, yep, exactly.
Does that make sense?
Cube.
Questions, concerns, childhood trauma?
And then times.
Childhood trauma.
That's it.
X to the 5th. And remember, that's all under 1. That makes sense? Perfect.
Does that like help? Does that help you guys
Yep.
understand better? Is there anything that you guys don't understand?
But it's all still under 1.
Maybe you're just like
remember?
completely
So it's
lost and don't even know what to ask.
I think I just need to look over this
Makes sense?
slowly,
Perfect.
Yeah,
get it in my brain.
yeah. It takes some time to get used to, but
2 3s.
Yeah.
It's the original problem.
cube.
So-
Yeah.
if there's anything else, feel free to stay and ask. If
Oh,
not,
yeah, 'cause it was outside.
you're good to go. Yeah.